Hello everyone, welcome to DS from scratch. In this particular video, I want to take you through fuzzy Siemens clustering. It's a clustering algorithm uh, which clusters the data not only for one particular cluster, but it will divide the data, or it will cluster the data into different clusters based on the membership value. Okay, so we will start our work by importing the libraries. We will be using Panda, NumPy, Matplotlib, and Seabird. Okay, so we will be working on a data set from USA housing dataset, in which we will have the location, the prices, and other parameters of the housing. So let's import the data. Data is equals to pd.read csv file name. Okay, let's look at into data. First five rows of the data, we have latitude, longitude, latitude, housing median age, and other parameters. So we will be applying our algorithm to the latitude and longitude. So we will be basically clustering the data into different regions. So let's just look into the location of the houses, or first let's just filter the data. We will be taking only the columns that we will be using for our work today. We will be needing latitude and also longitude. Okay, let's plot it. plt dot, or maybe scatter plot. Okay, data dot latitude, data dot longitude. Okay, let's plot it. So this is the location of the houses, latitude in the x-axis, and longitude in the y-axis. So based on latitude and longitude, we will be clustering the data into different regions. Okay, so first, starting fuzzy algorithm. In fuzzy algorithms, there are two hyperparameters. Okay, one is the number of the clusters, and another one is the fuzziness factors. Okay, first of all, we have to specify both of them. Number of clusters, which is k, or you can put any other variable. We can put it at 5, or how many clusters you want. And other one is fuzziness factors. It can be a value greater than a 1. Okay, so we can put 2, 3, or 4, or here we can use as 2. Okay, so starting with the algorithm, the first thing we have to do is we have to declare a matrix of the membership. It can be a random matrix. Okay, we can generate a random rand. Okay, the matrix size will be the the rows will be the number of samples, and the columns will be the number of the clusters. Okay, we can say that data dot shape, data dot shape 0, and the number of the clusters. So before this, we have to uh, uh, convert the data frame into array. So later on, it will be easy for us to use it. Okay, here we have converted it to, okay, array. Now we have declared the u value. Let's look at the u value, how it is. Okay, is not defined. There was capital K, and we have put small k. Okay, so this is the membership of the value. So the membership factors for each sample uh, should add up to 1. Like this row, each row sum should be 1, but here we have different numbers: 0 0.3, 0 0.01, 0.4. So it is more than 1, so we have to normalize it, so it will add up to 1. We can do this by dividing each sample by the summation of the rows, like, so dividing this number by the summation of the row, dividing this sample by the summation of the row, dividing this sample by the summation of the row. So we will do this for all the rows. np dot sum. Okay, u, we will add up with axis 1, we will add up like column wise, so they will add up into 1. And then we have to add a new axis, because that will be a one dimensional matrix. New axis. Okay, so let's look into new y. Okay, so the new y, if you add up, it will be 1 only. Okay, so after declaring our membership matrix, then we can calculate the centroids based on this matrix. So the centroids equation is like C is equals to the uh, summation of the multiplication of each column or cluster to the data over the summation of the clusters. Okay, so it's the summation of the membership. How do we do it? Np dot sum. Okay, summation of, and you all the row, like any column you want, it should be to the power of m to the power of fuzziness. Okay, and we have to change it to a two-dimensional array. New access, okay, times data. Okay, after this, in the denominator, it will come np dot sum u. Okay, the access of, okay, we can say that all the rows column 0. Now let's see if we have calculated the c properly or no. But here in the denominator also, the sum of u should be raised to the power of n, or to the power of fastness factor. Okay, okay, here one tank is missing, we have to add up with the access of 0. Okay, now you can see it has given us latitude and longitude. It is for the first centroid. So we are having, we should have 5 clusters. So there we need 5 centroids. For that, we will be using a for loop. For I in range of k. Okay, and we can declare a new variable of centroids, which is equal to np dot zeros. Okay, np dot zeros, number of clusters, and data dot shape, number of columns in our data. So we can save each centroid on its own cell or address. We can say that I, all the columns, is equal to np dot sum, and instead of 0 we can put I, instead of 0 we can put I. Now let's have a look to centroids. Okay, so we have successfully found the 5 centroids. Okay, first centroid, second, third, fourth, and fifth. So we have to change it in the form of a function. So because later on we will be needing this, we can say that define calculate calculate centroid, which parameters we will be using: data, obviously, number of clusters, obviously, and then the membership, obviously, and then the m factor. Okay, so what should it give us in return? Return should be centroid. Okay, now our function is ready. Okay, now the function is ready. Okay, after having the centroids, what we will do is we have to update the membership value. Okay, so for membership value, we will be using centroids for finding the membership of each dataset. For that, first we will be needing the distance from each point to the center. So suppose if the distance between the each data point to the centroid, we can say that np dot linear algebra dot norm, which is giving the Euclidean distance between the points to the centroid, dot norm data, we can say, and minus u, or uh, centroids. Okay, so centroids, all the row, like any column you want. uh, Access, I think we have to specify the access also. Access is equals to 1. Let's see what it gives to us. Okay, uh, okay, sorry, here we have a problem. row 1, all the column. Now this is the distance from each data point to the centroid 1. Okay, so we can do this for all other data points. Okay, for all other centroids. Okay, so for that we have to uh, again we will be needing a for loop for I in range of k, which is the number of clusters. Okay, again we can declare a new variable which can store all the distances. We can put this as u new. Okay, u new is equals to np dot zeros. Okay, data dot shape 0 and number of the clusters. Okay, so here again we can change this u new all the rows column I. Okay, is equals to column I all the columns. Now let's look at u new. Okay, again we have forgotten this. So this is the u new. U new is basically the distance from each point uh, to each centroid. So based on the distance we have to find the membership of the each value. For finding the membership we have another equation which we will be using that. Okay, our equation is, so we can say that u new sorry, u new is u new is equals to 1 over, okay, 2 over m minus 1 times n of sum of n of sum of 1 over u new. So this will be our a new membership u new 1 over u new to the power of 2 over m minus 1 times np dot sum of 1 over u new to the power of 2 over m minus 1 in the axis of 1. We will be adding a new axis. So let's look at our new membership value. Okay, u new. So this is the new membership value for each data point: 0 0.2, 0 0.2, 0 0.2, 0.19 and 0.11. If you add up all these values they will add up to 1. Okay, so the after having the new, we can again calculate the our centroids. Then again we can calculate the membership. Then we can divide we can assign the clusters to each data set. Okay, so how also after calculating the u new we can actually assign the labels to each clusters. Okay, suppose we have labels is equals to, what we can do is np dot or uh, max. Okay, or max u new axis is equals to 1. Okay, let's look at the labels. Control enter. So this will be the labels. Okay, which will be the cluster of the each data set. If we want to see this plot, sns dot scatter plot. Okay, data is equals to data, and x is equals to data all the rows column 0, and y is equals to uh, data all the rows column 1, and q should be our labels. Okay, let's see how the data looks. Okay, so after the first iteration we have this many clusters which we can say that it is not clustered well, or we can change the color to a better color so we can see. we can say see it better. So this is the first cluster. You can see that it has a cluster well. So what we have to do is we have to repeat this so many times, so it will give us a better cluster. We can say that for iteration, okay, in range of like max iteration, okay, in range of max iteration, what it has to do is it has calculate our centroid, okay, is equals to calculate centroid. What we need is data, then we need a number of clusters, okay, that second thing is number of clusters is equals to 5, then we need u, then we need the fuzziness factor which is 3, okay. After calculating the centroids, it should calculate the u new, okay, the new membership value. We can say calculate, okay. We have to put this also as a function, so we will be using that later, okay. We can say define calculate membership, okay. What we are needing here, we need data, we need centroids, we need number of classes, we need the fuzziness factor, okay. As a return, it should give us return you new, okay. If we run this function, okay, sorry again, as return, it will give us u new is equals to calculate membership, okay. We'll be needing data, then we'll be needing centroids, which is this value, okay. Control C, control V, and then which parameters we will be using. We'll be using k, which is the number of the clusters, and the number of fuzziness factor. So after getting the new, okay, we will assign the labels, okay. Labels, control C, control V. After getting the labels, okay, now we will see that if we will be using if function, if np dot lean algebra dot node, if the change in u new and u is not very big, so we will break the uh, so we will break the for loop, okay. No need to go further, and we can say that if it is less than or equal to, we will have a tolerance value 0.001. If the condition satisfies, then break the for loop. Otherwise, u is equals to u new, okay, u is equals to u new, and we can put this here, control X, and, uh, and labels is this, okay. So we can run this for loop, I think, without any problem. We have to specify the max iteration, how many iteration we want to do. Max iteration is equal to, suppose we want to do for 100 times, okay. Let's run this. So it will take some time, okay. Hopefully it has finished early. Now let's plot this again here, control C, control V. Okay, now you can see that how much the our cluster has changed from the first plot. This is the first cluster with only one iteration, and this is the second plot with 100 iterations. If we increase the iteration, if we play with the hyperparameters, number of clusters, or the fuzziness factors of the fuzzy Siemens algorithm, then our clustering algorithm may improve, and we will get the better cluster. But here obviously this cluster is much more better than the cluster which we got in the first iteration. So this was about the fuzzy Siemens algorithm. If you have any doubt or a query, you can comment, and please like and subscribe to the channel, so I will keep posting uh, other machine learning algorithms from supervised as well as the unsupervised algorithms from scratch for better understanding of the algorithms. Thank you so much.